us, a little bit of what this could be. Sanitation, Java, I feel like is playing actually just.
What? The streaming was going on? So anyway, so that's my plan. Now I'm focusing on to finish the introduction and course and then domain-driven design, and then what is a domain part until tonight, if it is possible. Okay, let's get going. Introduction.
Hi, my name is Wade, and I will be your instructor for this course. Before we jump into the course, though, I want to give you a bit of background about myself. I was introduced to domain-driven design several years ago when I joined a real estate company. Prior to that, I was working for a video game company, and when I was building video games, there wasn't a lot of opportunity to explore architectural patterns
and things like that.
When I joined
the
real
estate company,
I had a little more room for
that kind of things.
I was introduced to domain. For me, it sounded like
a really good idea. So I started researching it and reading blogs and things like that. And now I hope to do this with this course is to save you some of the research I have been so long into the domain time without having research I had to go through to understood it.
At the same time, I do think
it is a good idea if you really enjoy the domain design and spend some time material
there. So we will provide you with some materials that will help you.
Audio, stop the audio a little bit.
After the real estate company, I joined a company called Lightbend, and Lightbend is very focused on reactive architecture. We host events like the Reactive Summit every year. We also have blog posts and books that we put out on the topic of reactive. So we are very focused on the idea. What we want to do with this course is we want to present some of the parts of reactive architecture, specifically domain-driven design, in a way that will hopefully help you understand reactive architecture the way we try to understand. There are other courses in the Lightbend Reactive Architecture training path, and if you enjoy this one, then I hope you'll go on and look at those ones as well, because they will help to deepen your understanding.
Yeah, I'm done. I finished just the first course, which only took I'm done. I finished my first course, which only took like 4 minutes. And then the course requisite. Reactive architecture, domain-driven design is the second course in the reactive architecture learning path. You should either understand all the concepts of or have taken the first course in this learning path entitled Reactive Architecture Introduction to Reactive Systems. I think I understood it. So I'm gonna go next step, domain-driven design. Okay, I already finished the 2 sections of the lessons. Here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like this. So 25. What I like the most for doing this kind of activity is I really like it, just filling out something that I have done. In whether it's sometimes I'm more focused on to finish my activities, whether I understood or not, which is a very bad habit. But at the same time, it's a kind of supporting me to keep the study going. So that's nice. And yeah, so let me do that until today. Anyway, I've done this one and this one, and now I'm on lecture third. Oh goodness. Wait a sec. Yeah. So okay, that's better. And yep. Go. Let's begin.
When you start looking at
When you
reactive
start looking
architecture,
at the
you'll often come across the term domain-driven design, which refers to an architectural approach that is used to design large systems. Now, the guidelines or the rules that are set out by domain-driven design are actually highly compatible with those of reactive architecture. As it turns out, many of the goals of the two are very similar, they're very compatible. And so as a result, you'll often see them used together. Now, domain-driven design originates from a book called Domain-Driven Design, Tackling Complexity in the Heart of Software. That was written by Eric Evans. The goal, one of the key goals in the book, is to try to create a software implementation. One of the key goals in the heart of software. That was written by Eric Evans. The goal, one of the key goals in the book, is to try to create a software implementation. One of the key goals in the book is to try to create a software implementation that is based on an evolving model that is understood by the domain experts. So it's largely about creating a communication channel, you could say, between the domain experts and the software, creating a communication channel, you could say, between the domain experts and the software developers. We'll talk more about that in later videos, of course. Now, as far as goals go, domain-driven design, one of the key goals within it is to take a large system or a large domain rather, and to break it into smaller and smaller pieces. The problem that we have with large domains is that they can be very hard to model. There's a lot of rules, a lot of different things that we have to keep in mind when we're trying to model a large domain. And trying to do that all in one single coherent model can be very difficult or impossible in many cases. So because of that, we try to break things down into smaller pieces. This gives us a way to determine boundaries essentially between those smaller pieces within the larger domain. Microservices, reactive microservices specifically, have a similar goal. They need to be separated along clear boundaries, and in the case of reactive microservices, those boundaries need to be asynchronous. Each microservice has to have a clearly defined API and a specific set of responsibilities. If we don't know what the responsibilities of the microservice are, then it's going to be very hard to build it and design it properly. The trick comes when we try to determine what those boundaries are. There's no clearly defined technique that will just give us the right answer all the time. However, this is where domain-driven design can help us. It does give us a set of guidelines and a set of techniques that we can use to try to help us break larger domains into smaller domains. And because of that, we can take that logic and apply it to microservices to come out with something similar. Now, if you look at reactive frameworks such as Logom, for example, Logom is built with domain-driven design in mind, and it leverages some of its terminology.
Why it's so fast? Damn it.
If you look, for example, it has the concept of a persistent entity in Logom. That maps directly onto the concept of an entity, which comes from domain-driven design. And again, we'll talk more about that. Of course. The key here that we need to realize is that domain-driven design can be used in the absence of a reactive microservice or a reactive architecture. And you can build reactive architectures without domain-driven design. But because the two are very compatible and they do have similar goals, you'll often find them used together. And we are going to continue to do that in the course.
Maybe for now, having the speed 1 is much easier to follow. Instruction for review questions. Copy and paste all the contents here and go back to the questions. Time allowed unlimited with one okay. Finally, you will not be able to resubmit your answer. Okay, true or false? Many of the guidelines and rules in domain-driven design are compatible with those in the reactive architecture. It said yes. True. Domain-driven design key goals. What are some key goals of domain-driven design? Provide isolation for software designers to create models of the domain process without the bias or experience of business domain experts. Take a large domain or a system and then break it down into smaller pieces or subsections. Make domain model design the sole responsibility of domain experts. Create communication channels between domain experts and the software developer. So one of the key goals in this book is to try to create a software implemented that is based on a evolving model that is understood by the domain expert. Evolving model that is understood by the domain experts. Within it is to take a large system or a large domain rather and to break it into smaller and smaller pieces. I think these are the two is that domain-driven design can be used in the absence of a reactive microservice service or a reactive architecture. Make domain model design the sole responsibility of provide isolation for software designers to create models of domain processes without the bias or experience of business domain experts. Oh. Are you sure? Make domain model design the sole responsibility. As far as goals go for on okay, maybe I need to read it one more time. I think I just more focus on to follow the follow his speaking, not about the content itself. So yeah, I will read it one more time. When you start looking at a reactive architecture, you will often come across the term domain-driven design, which refers to an architectural approach that is used to design the large systems. Now, the guidelines or the rules that are set out by domain-driven design are actually highly compatible with those of reactive architecture. As it turns out, many of the goals of the two are very similar. They are very compatible, and so as a result, you will often see them used together. Now, domain-driven design originates from a book called Domain-Driven Design, Tackling Complexity in the Heart of Software, that was written by Eric Evans. One of the key goals in the book is to try to create a software implementation that is based on an evolving model that is understood by the domain experts. So it's largely about creating a communication channel, you could say, between the domain experts and the software developers. We'll talk more about that in a later video, of course. As far as goals go for domain-driven design, one of the key goals within it is to take a large system or a large domain rather and take a break and to break it into smaller and smaller pieces. One of the key goals within it is to take a large system and to break it into smaller and smaller and then program. The problem that we have with large domains is that they can be very hard to model. There's a lot of rules and lots of different things that we have to keep in mind when we are trying to model a large domain. Trying to do that all in one single coherent model can be very difficult or impossible in many cases. So because of that, we try to break things down into small pieces. This gives us a way to determine boundaries essentially between those smaller pieces within the large domain. Microservices, reactive microservices services specifically have a similar goal. They need to be spread along clear boundaries. In the case of reactive microservices, those boundaries need to be asynchronous. Each microservice has to have a clearly defined API and a specific set of responsibilities. If we don't know what the responsibilities of the microservice are, then it's going to be very hard to build it and design it properly. The trick comes when we try to determine what those boundaries are. There's no clearly defined technique that will just give us the right answer all of the time. However, this is where domain-driven design can help us. It does give us a set of guidelines and a set of techniques that we can use to try to help us break larger domains into smaller domains. Because of that, we can take that logic and apply it to microservices to come out with something similar. If you look at reactive frameworks such as Lagom For example, Lagom on is built with the domain-driven design in mind. It leverages some of its terminology. If you directly onto the concept of an entity which comes from domain-driven design. Again, we will talk more about the a little later in the course. The key here that we need to realize is that domain-driven design can be used in the absence of a reactive microservice or a reactive architecture. And you can build a reactive architecture without domain-driven design, but because of the two are very compatible and they do have similar goals, you will often find them used together. We are going to continue to do that in the course. That's quite tricky question. I think still one of them is correct. Create a communication channel between domain expert and software. Make domain model design the sole responsibility of. Okay. Note: make sure you select all of the correct options. They may be more than one. But I already took two. Technical and domain experts to interactively refine a conceptual model that address domain problem. Okay, so the domain-driven design, the first question here is this one, and then make domain model design the sole responsibility of a domain expert. Take a large domain. Okay, these two. I think still this one is a proper answer. The large domain or system, break it down into small pieces. Okay. Wow, that was challenging because previously when I just chose one and then if I chose a wrong one, then I got half of the score. Then all of a sudden I got a wrong answer result from this question, and then I already just checked these two, which cannot expected. But anyway, I just followed my answer that I got from the instruction. I was not very clear about this one, but still I was clear for this question. Oh my god. For this answer. So yeah, I could got the two attempts and then passed it. Large domain complexity. True force often a single all-inclusive model of a very large domain can contain much and at times overwhelming complexity. Breaking those large domains into small pieces can result in making the complexity more manageable and understandable. Maybe that's why we trying to break down a big chunk of the problem into small questions. large domain into small pieces. If we break down a large domain into smaller pieces, we need to clearly determine the boundaries of small pieces and how each piece and does or doesn't interact with the other pieces in the large domain. Design a model that puts the pieces back into a single understandable domain. This results in changes to the business or organization process. I think it's more logical instead of what I got from the instruction and the lecture description video clip that clearly determine the boundaries of the smaller pieces. That's very essential for make some partition of the big size of the node. So, sorry. Sure. This part it was not easy, but somehow I managed it to successfully done. And then that's the plan of today, which is unexpectedly easy to do so. So I think tomorrow and after tomorrow, by finishing, because I can contribute to my 8 hours into my study. So why not? I can do that. Eventually, I will finish the lesson 2 for this week. Then contribute the whole week of the next week to finish these 3. Like it. Then you know what? Instead of, I feel like I can finish like 3 lessons per week. Then instead of so those are overall. To be honest, it's not like a 20 hours work. It's more 25 hours work. It's more 20. And then for finishing all of these courses, I guess I can finish until May. Yes. For example, here 10 it's 11 12 today. It's 12 and 12. I can finish this one too. 12. $19, $26. What? $26 and then May 3, 10. May 10, May 17, 1, 2, 3, 4, 5, 6, 7. Yeah. And 24th. Something like this. So now I'm the fourth lecture.
So we've talked a little bit
So we
about
talked a little bit about where domain-driven design comes from, the origins of the history, but we really established
I'm not going to make any
the domain
assumptions
design.
here about
I'm not
what your
going
background is or what your understanding is. When I first started with domain-driven design, this term domain was kind of foreign to me, or at least it was foreign to me in this context. In order to do this in design, this term domain was kind of foreign to me, or at least it was foreign to me in this context. I didn't really understand context. I didn't really understand what the term meant in the context of software development. So first the first thing we need to do is to establish the meaning of what a domain is and what they are to achieve. So a domain, if you look at the dictionary definition, is going to be a sphere of knowledge. If you're talking about domain, you're talking about a specific area of knowledge, basically. And now, in the context of the software, they're changing a little bit, but not really at core, the same basic meaning. What it means in the context of software is to referring to a business or idea that they are trying to model. Typically, when you build a software, there is some sort of a concept or some sort of business we are trying to model, and there is our domain. Experts in the domain are therefore people to understand the business or that idea, and not necessarily to software. So if you are building banking software, for example, then you're going to have bankers are going to be domain experts. Your domain, first off, would be banking. You'll have your domain experts will be bankers, tellers,
you're going to have bank managers and potentially domain experts. So then
not necessarily
software. In our restaurant example, then it's going to be people like servers and the restaurant managers, your cooks, your shops, your dishwashers, all of the people are the potential domain experts. Essentially, if you go back to this is an exercise, the people listed can design is domain experts. So the goal of the domain design is building a model that is domain expert can understand. We are trying to build
these experts who, again, remember, they don't understand the software. We want to be able to take that model, present it to them, and have them understand them.
That's what I talk about.
This means that we need some sort of way of communication.
We are talking about that. But one thing I want to clarify here,
it's important to understand
it's important that the model is not the software.
That's a common misunderstanding.
That's common misunderstanding. People will look at the software and saying, this is my model. The model is not the software. The model presents our understanding of domain. Our knowledge of the understanding is the model. The software is an implementation of the model. We can implement the model itself. If we implement the model, for example, using diagrams, and it would be another implementation.
Around the model, that's another implementation of the model. So the model is not the software. The software is an implementation of the model. But the software should be implemented in such a way with a flex model. And as a result of that, if we talk about the model, then if that makes sense, we want those two things to reflect each other in a way that is very closely aligned, so that when we're talking about one, we are talking about the other. They don't differ so much that it creates issues in that communication. So on the topic of communication, in order to do this, we need a language that both the domain experts and the software developers can understand and can communicate with. Now, this language is what we call the ubiquitous language in domain-driven design. It is a common language that enables communication between the domain experts and the developers. Terminology in the ubiquitous language comes from the domain experts. So we go and we talk to the domain experts as developers, and we try to understand the words that they use, and we use those words in our model. In turn, we, of course, become domain experts because we are slowly learning about the actual domain. Now, words originate in the domain and are then used in software. We want to try to avoid going the other direction. We want to try to avoid taking software terms and introducing them into the ubiquitous language and forcing our domain experts to use them. There's exceptions to that. Sometimes that becomes necessary. Maybe there's a particular abstraction that the domain experts don't have a word for, but we need it in the software for some reason, and so we have to introduce that, and then maybe we should talk to the domain experts about it. But that's one key element there, is if we find ourselves in a need to introduce a term that doesn't exist in the domain as far as we know, we should talk to the domain experts about it. And the reason is because they might come back to us and say, oh, actually, we do have a word for that. It's, X, whatever X is. And so it's always very important to keep that communication going, and to do it in such a way that it allows you to maintain a conversation. If we start using highly technical terms like databases and database terms maybe, and event bus and entity and all of these types of things, our domain experts are going to get lost because they don't know what these things are. They know words like order, server, menu, cook, dishes. These are words that somebody who works in a restaurant can understand. They don't know anything about databases. If we start talking to them about databases and table indexes and things like that, we're going way over their head. So we need to make sure that we keep the language in using words that they understand. The idea here is that the domain experts and the software developers should be able to have a conversation about the software without resorting to software terms. And we can achieve that if we stick to the ubiquitous language and if we follow the rules of domain-driven design.
Instructions for review questions. Time allow unlimited. Okay. Okay. In the world of software architecture and development, a domain can be described as the portion of a URL that identifies the name of the website. In the world of software architecture and development, a domain can be described as a repository where code is packaged and stored, referring to the core group of developers in a given agile team, referring to a business or idea that we are trying to model. In the world of software architecture and development, a domain can be described as referring to a business or idea that we are trying to model. Domain. Typical domain experts in an insurance company are typical domain experts. Typical domain experts in an insurance company. Insurance company should have the climate adjuster, claims clerk, server, sysadmin, sales agent. Yeah. Yes, sure. Domain model. True or false? Domain model is a part of the software application. False, as we studied. True or false? Domain experts should be able to easily understand the domain model. All domain experts should be able to easily understand the domain model. Of course not. Is that what I easily just lose my score? Are you seriously? Jeez. I don't get that. So like this, one more time. Your bankers are gonna be domain experts. Oh, the word here, that's pretty complicated. So, what I have what I have understood is that the domain model, I thought it is a kind of a development term. Let's see. I know what's the domain expert is. Domain expert is in some domain, in one domain, particular domain. If a guy who knows a lot about that specific domain is the domain expert. Yes, true. There is no word of a domain model. How can I get to the point? Ah, jeez. So, we are trying to build a model that we can show to these experts who, again, remember, they don't understand the software. We want to be able to take the model okay, here. So the goal of domain-driven design then is to build a model that the domain experts can understand. So how? It doesn't make sense, the domain model. The domain model can be so in this term, if the domain experts can understand when about the somehow we tried to make a domain model, but actually it is not the domain model because the domain model cannot understand well. Okay, that's the point. Okay, I'll type that. There's no way to avoid it. The name of the form of communication that domain experts and software developers can understand is domain. The name of the form of communication that domain experts and software developers can understand is domain technology, universal language, ubiquitous language, common vernacular. I don't know what is vernacular means. vernacular. Vernacular. Vernacular is an like a vernacular, like a dialogue or something similar. Vernacular language is the speech the language of a dialect spoken by the ordinary people in a particular country or region. Okay, just put it that to my word list. vernacular, vernacular, nacular, vernacular. So the pronunciation of this?
Vernacular.
Vernacular, vernacular, vernacular. Again, what's the word of this? the language or dialect spoken by the ordinary people in a particular country or region. Vernacular. But anyway, so ubiquitous language. True or false? Domain experts provide language that is used in the software, and software developers provide the language that is used in the domain. Both provide input in equal proportions. I don't understand the question at all. Proportion is first of all, I'll try to check the word of proportion first. Proportion is pertaining to or according to the rules or principles of geometry. What? Proportion pertaining or according to the rules or principles of geometry. Domain experts provide a language that is used in the software. And software developers provide language that is used in the domain. Both provide input in equal proportions. No, of course not. Usually the software just make a model that the domain experts could understand, and they provide those languages translated to some technical term of software translated to the domain experts. True or false? If developers find a process or abstraction in a domain that doesn't appear to have a name, the developers should take the domain experts about whether it already exists or co-create a new term to describe it. And they're forcing our domain experts to use them. And there is exception to that. Sometimes that becomes necessary. Maybe there are particular abstraction that the domain experts don't have a word for, but we need it in the software for some reason. And so we have to introduce that, and then maybe we should talk to the domain experts about it. But that's one key element that is if we find ourselves in a need to introduce a term and that doesn't exist in the domain as far as we know, or we should talk to the domain experts about it. The reason is because they might come back to us and say, actually, we do have a word for that. It's X, whatever X is. So developers should talk to domain experts about whether it is already exists or co-create a new term to describe it. True. That's very true. So if I can finish the section I have, maybe I can finish it earlier. So yeah, somehow I finished this one. So it's pretty tired that I have finished like half of the lesson today, and then finished more 4 sections today as well. So I might have a chance to I better stop the work today here, and hopefully we'll come back tomorrow. Okay, see you, bye.